get to a quiz or a test, if it says find the sum, put a circle around it to remind yourself to find the sum. So if it says find the sum, it's geometric or telescoping. Of course, this is geometric. So I know I need to separate this to two separate sums. Oh, wait a second. Can you see it? 5 to the n over 4 to the n, n equal 1 to infinity. If I write out the first few terms, what do you see? Wait a second. Isn't r equal to 5/4? So that means that this sum diverges. So if one of the sums diverge, what do you know about the whole sum? Therefore, the whole sum diverge. Divergent means this adds up to infinity. It doesn't matter if this converges. It does, but it doesn't matter. Okay, so let's do this other one. It's not geometric, and I'm going to insist that you write out the S sub n. So it's going to be telescoping. So let's start off with doing partial sums. N plus 3. So I get A over n plus 1 plus B over n plus 3. I guess I don't really need parentheses there, right? Okay, so I'm going to multiply both sides by this denominator, right? Okay, so I get 2 on the left-hand side. And I would get A times n plus 3 plus B times n plus 1. Choose your wise numbers. So one of the wise numbers would be negative 3. So that would give me 2 equals negative 3 plus 1 is negative 2 times a B. So here I get B is equal to negative 1. The other wise number would be negative 1, right? Because that makes this 0. So then I get 2 is equal to 2a. So that means a is 1. Okay, let's plug that into here, right? So I'm taking this sum and I'm rewriting it. 1 over n plus 1 minus 1 over n plus 3. So make sure, in case you did something, like you did the partial fractions a little bit different, that you always have the negative in the middle. You always have the negative in the middle. All right, so now it's my turn. Do not split it up into two separate sums. It is your time to write out what the S sub n is equal to. So S sub n means you plug in n equal 1. So I get 1/2 minus 1/4. And then I plug in n equal 2. If I plug in n equal 2, I get 1/3 minus 1/5. And if I plug in n equals 3 plus 1 over 4 minus 1 over 6. Oh, there's not much canceling yet, is there? So let's just keep going. Oops. Okay, I'm at the end of the page here, so let me do it above here. Because I want you to be able to identify the pattern of canceling. Let's see what the n terms are. Okay, so that was n equals 3. So let's do n equal 4. N equal 4. So I would get, I'm plugging it into this, right? So 1/5 minus 1/7 plus, and then let's do n equal 5. 1 over 6 minus 1 over 8, right? Dot, 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 dot. Okay. I'm going to summarize it and put it up here so we can keep it organized because it matters, right? So 1/2 minus 1/4 plus 1/3 minus 1/5 plus 1/4 minus 1/6 minus plus 1/5 minus 1/7 plus 1/6 minus 1/8 plus dot, 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 dot. Okay, for sure we need the nth term. So the nth term is going to be 1 over n plus 1 minus 1 over n plus 3. Now let's also write out what the n minus first term is, right? This is the nth term. We should write a different color, n. The n minus first term means you plug in n equal minus 1 into there. So I have 1 over n minus 1 over n plus 2. So I do one more before that. If I plug in n minus 2, I want a different color. Well, go away, okay. N minus 2. Not very different color, is it? Okay, n minus 2. Okay, so I get a 1 plus 1 over n minus 1 minus a 1 over n plus 1. Okay, let's check out to see how the pattern of canceling goes. So 1/2, that stays. Oh, there it is, 1/4. Last one in this group, skip a group, first one in this group. 1/3, it stays. 1/5. Last one in this group, let me put a different color. Last one in this group, skip a group, first one in this group. Okay, let's look at this one. 1/6. Last one in this group, skip a group, first one in this group. Oh, hopefully you got to see the idea of how it cancels. So let's remind ourselves of what we have left in the beginning. We have a 1/2 and a 1/3. Okay, so let's see what else we've got here. So last one in this group, skip a group, first one, right? That would be gone in the dot, dot, dot. And this 1/8 would be negative 1/8 would be gone. And then, oh, I can see it. Negative 1 over n plus 1, 1 over n plus 1. And then last one in this group, skip a group, first one. Okay, what am I left with? I'm left with, and this is always going to be, if I have 2 first terms, I'm going to have 2 last terms. And again, I know you know the limit of these is going to be 0, but I will, and I want to see, I will get points, and I want to see that you can identify that pattern. So the sum is the limit as n goes to infinity of the s sub n. And so you know those two terms both go to 0, so I would just get 1/2 plus 1/3, and that's the sum of the infinite series.